Welcome to the 22nd episode of SecuriTEA Crumpets, where we host security professionals each month to talk about different security topics. Today, I'm delighted to have David Gilman on the show. David received his master's at Georgia Institute of Technology. His thesis was focused around securing egress traffic in cloud environments. David has worked as a product manager and a security engineer at various firms, but more recently, he is a senior security engineer at Instacart. Welcome, David. Welcome to the stream.
Thanks so much, Lewis.
All right, so the last time we saw each other, it was in Texas for LastCon.
Yeah.
Is that where you currently live?
So we relocated recently to Arizona, actually. We were in Austin for a few years. Really enjoyed getting to attend LastCon every year. I think it's one of the better local cons. But no, currently in Phoenix, and excited to check out CactusCon this year, which I think is kind of the only B-side style conference we have in Arizona.
Very cool. Well, my icebreaker for every episode is, where you live, what are the things you like to do and visit? I'll give you a pass, and you can talk about maybe things you enjoyed in Texas, but feel free to choose wherever you've lived, things you would like to do, like things you like to do and things you would recommend to the audience.
Yeah, absolutely. Well, I'd say in Austin, my fiance and I really enjoyed what you'd expect Austinites to like. So we do just kind of hiking around the city. There's a lot of green spaces there. It's for a city in Texas. Did a lot of eating. I like to cook. And then, of course, the coffee scene there is fantastic. Since moving to Arizona, the food, maybe not quite as good, at least the food around the around our neighborhood, but really been enjoying the outdoors here. Something that for some reason I didn't really expect or wasn't looking forward to. But as soon as we got here, kind of rediscovered my high school Eagle Scout self. And we've been hiking pretty much every weekend. We were just up in the mountains skiing and doing some snowshoeing. So that's been fantastic, honestly. So I've actually been pretty glad to be in Arizona for a few years.
I've only done snowshoeing once, but it was a lot of fun. It just kind of feels like you're walking on tennis rackets, which
yes,
is it's kind of a weird experience, but it's pretty cool. Got to see some interesting tracks where we decided to run away because they might have been better tracks.
Oh, wow. That's much more exciting. I was in a pretty populated area this weekend, so no bears, at least in the daytime, but that's cool. Was it in the UK or in the US?
Oh no, it was up in Tahoe. So
nice.
Yeah, it was kind of at a weird time where not many people were there. So it was interesting. I've been skiing a few times in Tahoe. That's the one great thing of California. You can get to loads of places like Big Bear. You can get to Tahoe. Like in general, it's a pretty great place to be.
Yeah, we're gonna be in LA next, so I'm excited to check out Mammoth.
Well, next time you're here, let me know.
I will.
All right. So, I've obviously we've only known each other for, I guess, about a year. But obviously your career has, kind of gone through a more traditional path, but I would love to hear, you're currently working at Instacart, which obviously is very popular, US delivery service, which, uses, kind of feels like an Uber in a way, but for food. Could you talk about like how you started in your career, how you got up, to where you are now, where you're working at Instacart? It would kind of be great to like learn the entire journey.
Yeah, absolutely. And it's funny you mentioned US-based delivery company. We certainly are US and Canada only, but I found that when talking to folks overseas, including at DEF CON, talking to some Israeli security folks, absolutely no idea what Instacart was. Whereas in the US, I find that's usually a household name. But yeah, as you mentioned, it's a Uber for groceries, essentially. I know there's quite a few platforms that do that overseas, including, I think, Uber, but in the US, we're usually the one people know. So my career, I got started, as you alluded to, in product management. While I was finishing up my undergrad degree, I had always had an interest in entrepreneurship, startups, and this was in like the early 2010s. So that was very prevalent, and like the cultural milieu was the idea of Silicon Valley startups, kind of this Airbnb, Instacart era. And so that was big in my mind, just regular entrepreneurship. And I had some coding skills, but really found product management to be an interesting way to get my career started, hopefully. And so I was working at a really small firm for about 2 years doing custom software for other small and medium businesses. And I really enjoyed that because it was a way to learn product management by exposure to a lot of different industries and a lot of different problems, use cases, technologies. So that was really cool. And I kind of wrapped up that experience by interning at IBM, which was a really cool summer. Kind of the only internship I did at like a big tech company. But I couldn't help feeling the whole time really jealous of the developers on my team, where I wanted to get in there, write stuff, break stuff, fix stuff, make new things myself. And I'd also always had this interest in cybersecurity, black hat hackers, NSA, reading all the books and blog posts and things, but hadn't done too much of it myself. But I started fiddling with CTFs. I joined a CTF team, started competing with them, just like small scale stuff, mostly web security and Jeopardy style CTFs, but really enjoyed that. Started getting some like wins and places in the collegiate leagues. And so decided, well, maybe I'll start applying for security jobs and product management jobs for my next move. Got a security job at a telecoms company called Viasat. And then I've been in security since then, just working in application and cloud security, mostly AWS, at a few companies, Viasat, then a company local to Texas called Favorite Delivery, then a company called mParticle, and now Instacart. So it's been really cool. I'm very glad that I kind of made that shift. I really do enjoy getting to write code and break things, and application security is one of the few areas that lets you do that.
Very cool. Now I have a weird question around this. So, you started out in product management. Did that give you a lot more kind of empathy to the traditional sense of where someone might always just have been in the technical space? And sometimes that takes a long time to realize that there's more to just writing code, right? So do you think your path kind of allowed you to be more empathetic to that situation, or do you just feel yeah?
I think so to some extent, certainly empathy. I don't know if it's maybe any better at my job. I think that's a bit like saying, I have good people skills at a party or something. Like if you have to say it, then it's probably not true, or at least you come across like kind of a jerk. But I do think that is at least giving me empathy. And I think that's helpful because, as we probably all know, listeners alike, that the trend now for a few years has been this idea of, shift left, a paved road, gates, et cetera, whatever kind of buzzword you want to put on it. And I think having a bit of that product management, user empathy kind of perspective is helpful. I don't think it's something that I have a monopoly on, but I think it's a great starting point for sure, thinking about how do we make it an easy user experience for developers to just kind of fall into the right security path instead of the old school way that we all know is bad now, where we just say no and block things and get fired for holding up the business.
Cool. Well, we'll definitely dig into that later, but
Cool.
I want to spend some time, we talked about how I believe my information is correct that you did your master's in egress filtering, and is that correct?
Yeah, so to be more specific, I throughout a great deal of my security career, I was working on my master's degree online at Georgia Tech, and part of that degree program, both the in-person and the online, which is they bill it as really the same degree, it's the same coursework. Part of the end of that, the graduation requirements are to do a project, not quite a formal thesis. It's more of a professional master's degree than an academic thesis granting one, but there is a final project with a paper. And I had this project idea problem in the back of my mind for a while around egress filtering, specifically in AWS, because that's what I've been most exposed to. And that's what I decided to do that final project and paper on.
Cool. This is really off topic, but how did you find your master's when it was all online? Was that a great fit for you? Did you see it being detrimental in some ways, or?
That's a good question. I have a lot of thoughts on that. I'm meaning to do a blog post at some point, kind of reviewing it. I got my start in this program with the OMSCS, the Computer Science Master's degree, which is a really well-known program, at least in certain parts of, I could say, the Valley. A lot of people get a master's that way if they're kind of taking that traditional get a bachelor's and go into the workforce way, but they still want a master's. So it's really an offshoot of that program, which is, as I said, I think really popular in terms of online master's degrees. I think it's definitely was a win for me and something I enjoy doing. And I recommend it to other people as long as you kind of understand what it's doing. As I mentioned, it's not a thesis granting master's. I do know people who've added a thesis on, and some people have used it to get into PhD programs, but it's not really what it's for. It's much more kind of a working professional's approach to a master's degree. But I would say that I'm definitely glad I did it, not just for the piece of paper, but it was really cool to have kind of the academic background to information security. So talking about the history of information security in some courses, as well as taking more of a math-based academic look at cryptography, just barely touching the surface of things like number theory. But that's kind of exposure I wouldn't really have gotten just working my job day to day. So all the different cool stuff. There was even a CTF class where you were graded on how many problems you got through every week, writing memory exploitation and stack and buffer overflows. And I definitely enjoyed that class quite a bit, even though it was pretty challenging.
Yeah, we had something similar in my degree, but it was like a traditional like do your paper kind of thing. I didn't do a master's, just did the bachelor's. But the funny thing was we had a similar CTF style thing where they accidentally left all the answers in the bin folder of the image. So I didn't realize that until the end, but everyone else probably spotted it earlier and was able to pass that class pretty easily.
Yeah, I mean, I think that's like that. What is it? That famous class I always see people referencing on LinkedIn where you pass the final exam by memorizing pi by cheating, essentially. I think it's kind of in the same vein. If you can run strings in a binary in undergrad, you probably deserve to pass the class.
It was kind of funny because that's actually what led to my that not that thing in particular, but my final year thesis was kind of like a product as well. And we built something called like security generator, we called it at the time, where it would build like vulnerable VMs on the fly so people couldn't cheat anymore. So everything was kind of like, different parameters are vulnerable to SQL injection, or you would arbitrarily choose like a different CVE that you would have to like go and discover kind of thing, which was
That's still really cool.
They still use it today. But it's by like the code basically is no longer mine 100%. I wrote like the initial MVP and then moved on. But I think
awesome.
it's a really interesting component. So I would, obviously this is going to be releasing just after CactusCon, where you're also going to be talking about egress filtering in AWS. Some of the listeners obviously might be very new to this field, or they might not know what Ingress and egress, type things are. Could you talk about what that means in general and how it applies to like AWS?
Yeah, the straightforward explanation, thinking about a web server, let's say, something serving static or dynamic content over the internet, is that ingress traffic is kind of the traffic you'd expect. So it's clients, people's browsers, making requests to your web servers to load resources, maybe even send data to like a RESTful API. And these requests, they're ingress because they're originating from the client usually outside of your network, at least in this context. Whereas egress are requests originating from what you would usually think of as your servers. So your servers would be clients to some other server in that respect, but your servers would be egress. So it's exiting the network. And what's interesting is that a lot of thinking about like web servers and APIs, most of these workflows don't have a lot of egress traffic, but the traffic they do have tends to be very necessary for reasons maybe we can talk about later. But it's also an area that tends to be ignored for reasons such as it's difficult to deal with. And some people are still operating with the assumption of kind of this perimeter approach where, well, if an attacker gets in, well, first of all, maybe an attacker won't get in, right? We have super great security, we bought a firewall, no one will ever get in. Or, well, if they do get in, it's game over. So, why do we need to secure it at all?
Interesting. And then when you like, I guess for would you generally treat egress filtering more for I guess what your company users might be doing inside, like let's say like the office, or is this more intended for people who are more worried about the servers that are running your production applications, housing where your databases are, like that kind of traffic? Is that where kind of the line kind of starts to like I guess split?
That's a good question and a good point, is that another type of egress traffic would be your employees maybe using a VPN exit node or just in a physical office location, browsing the web, going to their Gmail accounts, watching Netflix on the job, etc. That would also be egress traffic. I think my focus has just been more of the cloud because that's more my background and more what I've been tasked in my career to deal with is things closer to the code that makes up the business's core business rather than maybe more traditional IT security. But that's certainly an area that is also egress. Could be egress traffic as well as again, like people's traffic leaving a corporate office or VPN.
Cool. It doesn't really seem like a popular topic to talk about. Like I've seen a couple of blog posts, and we'll dive into one of those a little bit later and get your thoughts on it. But like, why do you think it's not a very popular topic? Is it just because like, well, this is very basic, fundamentals, or yeah?
Well, I think it's just because it's hard and because there isn't a lot of reason to deal with it. One of the things I mentioned in my talk that I'll be giving at CactusCon is that there actually is a requirement for PCI DSS, that you filter or have control of your egress traffic. And in AWS, at least, and I'd say most cloud environments, most organizations are simply doing the default, which is to allow all outbound traffic. For security groups, for example, you just add a rule, allow any all outbound, and then that's the end of the story. I know in traditional networking and in some cloud environments, this is addressed by having some, maybe blocking some unused ports, or then you can pass an audit by pointing at those rules you've added that don't really do anything because there's no traffic on those ports, or black box solution of purchase a actual or virtual appliance of some kind. Your traffic leads through this firewall. It shoots off alerts if it sees things that match, the Suricata or snort rules that are loaded on by the vendor, but it's a pretty reactive stance.
Okay. Now, let's say, what would be the end game when it comes to not having good controls around egress filtering? What would be the general concerns, the different types of, what could generally happen in that scenario?
Yeah, so this is really a defense in-depth control, which again, I think is one of the reasons that it's not as popular to talk about, besides the difficulty of it. I think there are lots of attacks that can be prevented with these controls, but it's always as a secondary control. And so one example would be an attacker gets malware of some kind on a server in your cloud environment. And this could be in a number of ways. You're thinking about RCE, but a way that's particularly relevant recently has been around supply chain. And I'm always a little reluctant to bring this up because, every vendor is in everyone's inbox talking about SBOMs and supply chain and et cetera, but I do think it's really valid here. And again, one of the points I've made when talking to peers inside my own organization, and then in this work, has been that egress controls are a great way to essentially stop an attacker who's compromised a package or a commercial tool. And starting to dive into the technical details a bit, how this works, short answer at least, is that if you have an allow list of, I guess we'll talk about some of the nuance here, but domains or IPs, and the freehomework.com or whatnot domain that your adversary has registered for command and control is not on that list, then short answer is they won't be able to connect to it. And we've seen this with Sunburst, for example, which was, again, vendors' breach of choice, I think, to sell us on SBOM products in the last few years. But in reality is if organizations had been able to implement these types of egress controls, the attacker, even with remote code execution, the malware wouldn't have phoned home. Specifically for these broad campaigns, it just would have looked like the infection didn't take. Would have been hard for them or impossible for them to differentiate between egress filtering that they might have been able to overcome and just absolutely no traction, or that they were actually detected.
I liked the the story behind that, because the way that I see, as we do quote unquote, defense in depth mechanisms, right? A lot of the people say because it's a defense in depth thing, it's not as important as doing something that's absolutely critical to the business, right? And I've seen it time and time again about how these small, incremental defense in depth changes can actually lead to less compromise, right? Think about the web browser. When people started to add content security policy, it's not a silver bullet, right? But sometimes people have actually fixed cross-site scripting because they actually were getting alerted about the use of JavaScript in a strange way that they weren't interpreting it right or expecting it to be received. So I like that how those types of things also translate to I guess the things like egress filtering, best practices.
Mm-hmm.
Now, could you talk about some of, obviously, if you're sending data out the network, you want to try and bypass some of these things, right? The generic snort rules, all these different things, right? What are some of the techniques that attackers might use to try and bypass the general commercial products, or maybe your homegrown kind of filtering stuff?
Yeah, and I'd say there's really, like most controls, there's kind of two broad categories here. One would be more preventative and one would be more detective. Obviously, anything that's preventative should also be detective. If you have a rule that prevents some sort of malicious activity, it should also be able to send you an alert when it blocks that activity. But an ideal end state, if possible, for a control, I would tend to lean more towards the preventative. It's just, can the technology tolerate that sort of false positive ratio or the noise to get that adoption up? At least that's my kind of view on controls at a high level. I don't think that's anything too controversial. But regardless, in terms of these different mitigations, there's a few things that attackers we know have done. And things that we can think ways to evade. And in my talk, I reference some work other folks have done, both in analyzing malware specifically, and then also kind of thinking about how would you evade the kind of controls that AWS, for example, gives you out of the box. One of the big things is DNS over HTTPS. So this is something that I first heard about a few years ago with this whole debate, DNS over HTTPS or DOH versus DNS over TLS, DOT. People get it confused with DNSSEC, which has a different aim as a control. But the short explanation here, without hopefully ruffling any feathers in this security religious war, of which there are many, is that DNS over HTTPS is a way to resolve a domain. So to turn a domain name into an IP address, but over an HTTPS connection, which means that unless you, the defender, are viewing this connection on the machine it originates from before the connection is made, or are doing TLS packet inspection, where you're serving as like a man-in-the-middle proxy and removing the encryption, you can't see what's inside. You can see where it's going at the IP layer, the final destination IP, but you can't actually see the question or the response portion of the DNS request. So that means that as an attacker, if I write some malware and I have a command and control domain that is suspicious, or maybe you even know about, but my malware is set up to resolve it at Google's DNS resolver, you'll just see a DNS request to quad 8, 8.8.8, or some other resolver, and you have no idea what's in there. So then the attacker, the malware can make that request, get back an IP as provided by the attacker's DNS records that they've configured, and then the malware can make a regular HTTP request to that IP. So that allows them some more flexibility, some avoidance of detection, and it's something that's been used in at least one set of malware. I really like that. I think I know it breaks quite a few defenses. There's a lot of assumptions, that I've seen for products or techniques that try to prevent these sort of attacks. And it's things like, we'll just look at the SNI on the TLS connection, or we'll look at the DNS requests. But if it just circumvents it with state-of-the-art encryption over TLS 1.2 or 1.3, then you have fewer options. So that's one technique that's been seen in the wild for AWS malware specifically that I think is really good and doesn't have a simple defense.
Cool. Yeah, this is definitely not an area I ever look into, so it's kind of fascinating to me to hear, some of these approaches. It makes sense. I also, recently saw that someone was using Reddit as a way to kind of experiment with like exfiltration of data. So I think, there's another question is like, okay, you have these legitimate services that realistically people might reach out to. It's very possible. They were using it like in threads, and they were like sending commands, via the thread, and then it was all going through in a traditional network that would look fine, like realistically, right? So is there anything you can do in that scenario, or is it, you're kind of like, well, this looks like legitimate traffic, so there's not much we can really do here?
Yeah, good question. I mean, I think that's why they're using it, right? Is that at least superficially it's going to look legit. And I know there's been C2 and malware drive-by attacks through all sorts of means like this, right? Discord at one point was having an issue with this with their CDN. Other CDN providers, I'm sure, have had similar issues. I know IRC has been famously used for C2, Twitter even. I think I've seen research along those lines. I think that gets into, let's say you as an organization are trying to do egress controls. I think that starts to get into how robust and how mature are your other controls. Because if there's some sort of, if all your traffic is leaving through one router or something like that, maybe you're a small company and your servers are in the office, you have a rack in a closet somewhere, or maybe you have everyone's off site and then everyone's connecting into a full tunnel VPN, and then that's all outbound. And I've seen this a lot too, as an aside, guard duty, for example, AWS's sort of detection rules just right out of the box package is really noisy when you have a VPN exit node, because it's seeing all sorts of stuff that production servers shouldn't be talking to. It's seeing weird domains for ad tracking purposes and all sorts of stuff. And so it can be really noisy if you're having it look at like your full tunnel VPN. So all that to say, I think that egress controls, as I talk about them, are vulnerable to that, depending on how they're configured, because really what you need is another set of controls, which would be like network segmentation. In other words, you should know, is it someone's traffic on their laptop, in which case Reddit's probably okay, depending on how draconian your IT department is. versus production servers, unless there's some very specific business case, probably should never be talking to reddit.com, in which case you won't add it to your allow list. And via the controls we can talk about a little later, they shouldn't be able to connect. But again, if due to scale or tech debt of some kind, all your outbound traffic is kind of mixed together, then it would be really hard to detect and prevent that.
Gotcha. Like, I think, you sent me over the Lyft engineering blog, which I'll definitely like show up on the stream. I think their like core approach was around like observability and restriction, right? So I think what you're saying is kind of like how like larger organizations are also trying to approach the problem, where you want to make it really easy for someone to be able to set up a new service, but you also want to be able to have those particular restrictions where like, you're not talking to every kind of domain, right? You're talking to only the approved services in like an allow list or something of that nature, right? So based on like Lyft's approach, like, is that kind of like how you envision most companies should approach it, or is it like were there like things that they could have done better, or do you think that's the best way to kind of think about this in this space right now?
Yeah, I was really excited when this post came out because, as you mentioned earlier, you don't see that much discussion. I think it's such a commercial problem. There's not much in the academic like literature that, and I certainly am not an expert on that, but what I've seen when I was doing a little bit of research was not much on this topic because it's so much more, the technical solutions are there. This doesn't need someone with a PhD to come up with the idea of allowed lists or block lists. It's just that it's hard to implement in practice, because how do you maintain an allow list of every single domain or IP that your servers legitimately talk to? That's a difficult problem. Or how do you maintain a block list of every single evil domain or IP? That's literally an impossible problem. So I was really excited to see someone having done this in the real world. I chatted with the author a little bit. And really definitely recommend checking out this blog post if you want to hear how someone did it in the real world. I think what Lyft has going for them, besides money, resources, a huge security and engineering team of highly talented people, is that they're also, I believe, the creators and maintainers of Envoy, this proxy that they run right next to their workloads as like a sidecar proxy. And so they had that as a starting point. And what I'd like to contrast that with is there's a blog post that AWS put out, and it's continued to update, where one of their potential solutions to this problem is to spin up some compute, like in an EC2, and deploy a proxy on it. And then this could be horizontally scaled. And then you send all your egress traffic to these proxies. And then they can institute block lists or allow lists based on things like domain or IP. Now, one of the problems with this is it's really hard, at least in my experience, to go to like a CTO and say, hey, we need to spin up all this extra compute. If it goes down, everything will stop working. It's a new technology to support. Like some of my previous employers, we had a lot of egress traffic. We had about as much egress as ingress, which is unusual, but it was just due to the nature of our product. But in that case, especially the cost for all this compute would be insanely high. And so it's a big ask in terms of cost, in terms of risk to availability. And then their particular approach still has some issues around things like using TLS to evade it or whatnot. Contrasting that to Lyft's approach, they already had these sidecar proxies deployed. The traffic is already going through them in many or most cases, and they're sitting right there. So there's no risk. There's no additional risk in terms of having to deploy, maintain, getting paged in the middle of the night for them. They just use the existing tooling to add on some level of both explicit and transparent proxying, which I'd recommend folks read the article to see a discussion of that. But the short explanation is that they already had these proxies deployed as sidecars. And so it's easier for them to spin up this idea of allow lists for different services. And one of the best things about this, besides avoiding that additional risk, was that they got to be really granular. They have the conception of specific services should only be able to talk to specific domains, which I think is phenomenal. That's such a level of granularity that even if some domain is compromised or something, you're limiting your blast radius to just one specific set of services. So I found that really impressive. And I'm glad to put that out there for everyone to take a look at.
Very cool. That was a great kind of like overall description of how they kind of approached it. I would like to take a step back and like, let's say that, I have none of this. I don't have any proxies. I'm just allowing everything through right now. this is obviously pretty traditional, especially like, more immature companies who are like just kind of, they might have just started moving to the cloud, or they, may have been in the cloud for a long time and they had to keep things, open for like various reasons. What would be some of the kind of, rather than just trying to like deploy a proxy or do this EC2 computing stuff, which obviously would be very expensive, what would be like the kind of initial steps that someone would want to do if they already have a setup in place in like, let's just say AWS? Like, what would be the first like, factors?
Yeah, good question. I think two steps that go like hand in hand would be, if you can afford it, turn on guard duty. Again, there's a lot of rules in there. Some of them are better than others. There's definitely some noise, but for a smaller company, the bill should hopefully be handleable. And I would say that it is worth the investment if possible, just as like a first simple control. Definitely something that as you grow, you can hopefully move away from, but it's a starting point, and it will detect some of these possible things like high entropy domains that are representative potentially of malware generated domains, which use an algorithm, domain generated algorithms, to create sort of like a hash in a way where both the client and the server can figure out what the domain is going to be, and then they'll both connect to it, but it's not in the code anywhere. So you as a defender can't just look at strings and see the domain, and it changes over time. There's a lot of noise, but that's one way to start. And then I would say closely paired to that would be the network segmentation things I talked about earlier. So to avoid noise, you're ideally going to want to start to think about, prod versus dev versus the in-office or the proxy environment. And therefore, you're not going to be getting, you can turn off the kind of noisy alerts that you're going to be getting from the office network versus the production network. And also, hopefully, you're not going to be paying for the traffic that's coming from the office network or the dev network.
That's interesting. And, obviously, as people start to scale, with like things like egress filtering, how do you prevent that being like a bottleneck too? Because sometimes like you might be overly like kind of say that there is a lot of noise. As long as you're in like, like, I don't know if this is the same concept here, but you can have like alert mode and like block mode and all those different types of things. Like, how do you kind of like minimize that risk where you're not kind of, potentially taking down services by implementing like these kind of filters too?
Yeah, I totally agree. And so I think when you're ready for moving from a purely detective control to one that is preventative, I think that's exactly right. I mean, I really like that model. I think you see that kind of approach taken with all sorts of controls, from CSPs, like you mentioned earlier, to different approaches to egress filtering. I think that's definitely the approach. I think the details of it depend on the implementation that you choose. But for example, I wrote in my master's work, I wrote a pretty crude service, which would, as part of it, check DNS resolution against an allow list. And so it also had like this idea of a block versus prevent mode. And so you could add things to a file or flip a flag potentially, and then move. And so I think it's very similar for those folks who are more in the AppSec space, like a content security policy. So listen, watch. If you really have the resources, take a look through the file before you enforce it. Most of us probably don't have the resources, and we'll just move straight from report to block mode. But even that can be really, really powerful.
And are there like things today where there's like programmatic ways to do this from like a learning model perspective, or like learning over time? Does that exist in this world? Or
I haven't seen anything that does it in a way like CSP, other than some of the commercial products out there. So there are some commercial products. I don't have a lot of hands-on testing of them. I've kind of evaluated them based on their marketing materials. I think some do a better job than others, kind of depending on, are they trying to, check a box for a CISO somewhere, or are they trying to actually address some of these more state-of-the-art things? But yeah, I think if you're just trying to do this yourself with AWS tooling or off-the-shelf open source tooling, probably going to have to kind of do that aspect yourself, at least with what I'm aware of. But it shouldn't be insurmountable. I think the hard part here in my mind is addressing those questions of like cost and availability for your engineering team. And then also, how do you do this in a way that you can keep up to date? Because that's the other challenge with allow lists, is even if you have that good, detection, and then you start enforcing that, what happens as soon as someone adds something else to the CI/CD pipeline, or a new language even, right? And they need to pull from a new package repository. It's probably good as a security team, that, right? kind of like CSP when it catches marketing, adding some new like tracking pixel to your website, and they're not following the policy. But you have to have a team that has the bandwidth to support that. And I'd also say that if it ends up in a flow where you're just clicking accept, 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 then it kind of becomes worthless. If you're just allowing everything through, why do you have a review process? But these are the kind of problems that I think a lot of us in AppSec or InfraSec face, just in terms of big picture. How do we have an approval process that has some teeth but doesn't hold things up? It's a fine line.
Very cool. And as I obviously I wanted to ask more about your academia work, but I think would you say because it was more like related to work that it was more like practical than theoretical, or was a lot of this still like quite theoretical?
I think it was relatively practical. I think what it was that was very simple. It was, a semester's worth of work by one person in addition to my day job. So if you take a look at the code on GitHub, you'll see that I really, with permission, built it on top of someone else's Python stub resolver. So pretty crude. But I can talk a little bit about my thought process here. So thinking through this idea of how do we create an allow list of essentially domains that we know are good. Again, not an easy problem, but one we can potentially solve by recording traffic, then maybe setting to enforce mode. But we don't want to send all the traffic to a third party, like a man-in-the-middle deep packet inspection proxy, or even the AWS approach. How do we do that without having availability concerns, or at least less availability concerns? So my thought process here was not a lot, but some companies run their own DNS resolution in the cloud or on-prem. Others, most, I would say, probably just use the AWS Route 53 resolver. That's fine. And they have some cool security controls as well around this, though they're not perfect. But if you're willing to run your own resolver, your own stub resolver, then this will handle outbound DNS resolution, have a cache, everything like that. But so that will have to handle a relatively small amount of traffic, just the DNS requests. The rest of the traffic will leave the network like normal, but I chose to, when the key piece here is that when a DNS resolution happens, if that domain is on the allow list, it will return the IP like normal, but it will also add a rule that allows outbound connection via security group to that resource. And so what that means is that most of the traffic doesn't actually have to go through this extra service, only the DNS resolution traffic. It also means that the downtime is limited in terms of if you're caching those DNS resolutions, then a temporary blip in availability for the domain service, the resolver won't have as big of an effect on the rest of the traffic. You don't have to pay for these really beefy instances. You're just relying as much as possible on the built-in AWS infrastructure. And some of the other side effects of this are if an attacker avoids DNS resolution, if they hard code an IP, they'll simply fail at the security group level. And if they try to do some like SNI spoofing or DNS over HTTPS resolution, then again, when they try to connect to Quad 8 or some other DNS over HTTPS resolver, that won't be in the allow list, and it will simply fail at that stage. So it kind of addresses both the availability concerns and the some of the other security concerns that maybe other solutions don't address. I'd say downsides of it are you are still introducing a third party, and so there's this stub resolver, so that definitely has potential complexity. And I haven't seen it productionalized. I've seen some other approaches that I think take a similar approach without having to manage your own resolvers in your network, which are probably better. But I certainly enjoyed playing with the problem and kind of thinking about all the different TTPs an attacker might use.
Very cool. I'll make sure that your or at least a reference to it will be like linked on the blog as well, just because I looked at it, it's I've only looked at like, someone's like two people's theses all the way down, and one was my old PhD professor. I never finished the PhD. Different conversation for a different day. I want to move away from Egress now, and and we can. I kind of want to do like a build your own journey situation here,
Sure.
kind of like like let's choose our own adventure in a way, and talk about building and scaling. So in this, especially like in like startups in small, like kind of like very kind of high productive teams, you kind of need to do a lot of like building of your own like solutions or incorporating solutions, but scaling around that as well. You've worked at various organizations as a security engineer, and you've been involved in some of the processes of like supply chain or like static analysis. based on, which one is more interesting for you? Let's start there.
SaaS or supply chain?
Yeah.
I think right now supply chain, because it's an area that's getting a lot of attention, I think for good and bad reasons. And just today I was chatting with a colleague about it.
Okay.
So it's certainly top of mind for me.
Okay. So let's choose supply chain. Obviously supply chain encompasses a lot of different things, right? One of the obviously the biggest things right now in people's headspaces is like, the third-party dependencies, software eats the world situation. It's 2023. You were just talking to your colleague about it the other day, and from what I've seen, people really kind of are really upset with today's tooling, and we won't name names in it, and this is a very vendor agnostic stream here, so we won't talk about names, but what are your thoughts today on the supply chain kind of tools that exist today? Are you upset with the false positive ratio? Like, do you think things are over reporting? Do you think things are just kind of screaming Hail Mary and it's actually like no, like it's not very beneficial? Like what is your general like just thoughts, things?
Sure. Yeah, and I definitely have a few. I think that also, not only is this obviously not the perspective of my employer, but it's also just my opinion. And I would say that people, if you talk to 4 security engineers at my employer alone, you'll hear like 8 opinions. So it's just my thoughts today. But I think, and this probably won't come to a surprise to your audience, but I definitely, a big complaint of mine is the noisiness of a lot of these tools. I think it's funny though. I think there's a portion of the security community that's very aware of this, that, as I would put it, there's been a lot of, I would say FUD, fear, uncertainty, doubt being sold. Of some of it's based on real issues, but then the solutions maybe are not ones that I would view as like a technical solution to the problems. You can think of things like, I would compare this to zero trust in that regard, right? A good idea, sounds like implemented really well at Google. Some of the technical controls are things we should all do, but if I get an email about zero trust, I'm not reading it any further. It just kind of sets off my BS detectors at this point. But yeah, for vulnerability management, particularly in the AppSec space, for me, I think like a lot of other security engineers, big challenge is just how noisy these things are. We did kind of at a particular employer, we did sort of a soft experiment of, let's actually go through and start triaging these and see how many of these are exploitable. And it was 1% or less. And I've anecdotally seen very similar results from other peers in the industry. I know at least one household name company that says their approach is they just don't patch anything unless it's like a shell shock level vulnerability that they know can be exploited, or log4shell. They simply just don't worry about the rest. And I have to say, I'm pretty envious of them just not dealing with that problem. I think it sucks up a lot of oxygen for a very low return on investment.
Yeah, there's definitely, from my experience over the years, a lot of the times, like, consultancies, pen testing, anything just tries to like fluff out a report because you want to make sure you reported the same thing last time, even if they haven't fixed them in the past 3 years. It kind of like comes to a standstill where it's like, well, if things haven't been fixed in the past 3 years, is it really a problem like to this organization? Maybe we should change it. But like that's kind of like what I've been seeing, and it's the same in the tooling space, right? Everyone wants to make sure that they have the same kind of coverage as other tools. And I think my biggest kind of gripe with everything is just, were those tools capturing the right things, the metrics in the first place? I really, most of the time I'm like, well, they're still reporting on vulnerabilities that are actually patched 4 years ago, but because of it's an interesting concept and maybe something that they coined, they still flag it even though it was fixed 4 years ago for this like individual package or library or something. So I find it really difficult these days to kind of like get, like, I've been talking about the sea of data in my last podcast, but this is more of the sea of noise. Like, how do you like shuffle through the things that matter? Like from your experience, like what has been like successful for you, and maybe some of the conversations you've had with peers where you've been able to kind of like break down the noise barrier, because it loses trust with, you try and roll this out to your developers, they get a bunch of noise, it's not beneficial. So like, yeah, I'm ranting myself, but I would love to get your opinion.
No, I mean, I think that's certainly one thing not to do, is this very old school idea of, okay, we have all these vulnerabilities. We're going to create a ticket for each one, and we'll set severity based on the CVSS score or whatever our tool says, and we'll open them all up in Jira, and then we'll be really mad at you if you don't fix them. And good luck. Here's 10,000 vulnerabilities on Monday. I think enough people have gotten in trouble with that approach that they realize it's counterproductive. I think a close second worst approach is okay, we'll do that, but we'll start with the highs and crits. And I've seen this, I think, around some like US government messaging to their constituent parts, things like that. And of course, one of the many problems of that approach is the idea that high and crit, according to CVSS, or a tool is a high and crit in your environment. I like your point about, hasn't been exploited in 3 years. Is it really a problem? I think that it's hard to explain the nuance to both someone who hasn't kind of had to deal with this problem, even if I'm thinking about maybe myself coming out of school where, I know my OWASP top 10 and I know about, third-party vulnerabilities. And so I'm thinking, got to patch them all. All those are vulnerabilities. I think it was Equifax, right? They got hacked because they didn't patch their Microsoft server or email server, whatever it was on the edge of their network. And so we're, oh my God, there's 10,000 of these. Like, how are we going to fix them all? But then you begin to realize it's not only kind of alert fatigue, but it's also the realization that they don't matter. And to a large degree, they're not exploitable because you're not using that package, you're not calling that function, or there is no patch. That was something I remember early in my career seeing was, okay, I created a golden image for our team to use. It's sick. I did all the right hardening guides, it's going to be hack proof, completely up to date. And I'm still getting alerts from AWS Inspector that there's unpatched kernel vulnerabilities because no one's ever written a patch for them. And it's like, well, then, how severe could it be if every single Ubuntu box in the world has this vulnerability? How do we really need to? We can't even patch it if we wanted to. So how bad could it be? And so you start to see some of that in vendors, right? With filtering your vulnerabilities by, is there even a patch available? But I am excited about some of the things I've seen from open source and commercial tooling that I know you're aware of around reachability, for example. I think there's one really great metric that I hope continues to grow. I've seen a few vendors start to offer that. The Go community recently came out with their own open source approach, which I think is awesome. I'd love to see that. I think it's really cool to have that sort of thing just out of the box in a language. But I think it's going to take a while for kind of hopefully no one will get mad at me, but the CISOs of the world and such to kind of come around to this idea, and the compliance regimes, the SOC 2s, PCIs, to come around to this idea that measuring vulnerabilities based on output of a scanning tool is a counterproductive way to spend security's time.
I have very similar thoughts around this space. There's where do I even get started? There's so many components where like things like tools that are like reporting on compliance stuff that like, oh, you have to go and fix these images. Well, actually it's not reachable at all. And how do I actually go about fixing that? Is we basically still have to fix it somehow. So like, can we like use a different library that's not vulnerable? And it actually like impacts development. It really does. So let's say, I obviously you've been at a few companies, not everyone's approach is the same, but let's say that, you are starting at a new company and you get there, you realize they're not doing anything for like dependency scanning. They're, what would be, and obviously one of your first tasks is to go and figure out like how to like, move forward in this domain. Like what would be like your kind of like success criteria in a way to like make sure that you do your job effectively and the organization sees like huge impact and benefit from the work that you basically get tasked to do? This is a really like
sounds like an interview question.
Loaded. I'm not trying to well, I'd love to hire you, but a different conversation. What would you say?
Well, I mean, one question I'd ask both in if you were interviewing me for a job or if this was my first day somewhere would be, how are you, my boss, or how is the rest of the org going to judge? How are you judging success here?
It's exactly why I brought you on, because I'm trying to hire you. No, I'm just kidding. Okay. Let's say that they tried to do something before. It was way too noisy and they were like, we can't do this, and they just turned it off. Like, what would you say in that scenario?
Yeah, I think that's common, right? there's a few vendors, or maybe even open source tools that will give you this kind of just spew of data, if that's what you're looking for. I think one thing is starting from first principles and understanding, like, why do we care about this and what do we have to do? Is it that, is that there's an understanding just generally like patching is the right thing to do? Is it that, we're getting customer questionnaires of how many vulnerabilities you have in your environment that are unpatched? Is it, we need to be able to answer our compliance questionnaires, or the GRC team is pushing on it because they have to answer the compliance questionnaires? So I think understanding that sort of like why is always super important for security, because, it's like why egress controls. Egress controls, just to pivot back, that could be the wrong control. If you're one security engineer, you get there day one. I don't know if I'd really advise that would be your first thing to do, because it's a defense in depth measure. There's probably, passwords probably aren't being salted, or they're, being hashed with SHA-1 or something. Like do that first and then think about defense in depth. So I think understanding the why is super important. But then from there, I think technical controls wise, I'm kind of a big fan of, let's just not do it right now. Are we getting hacked to do it? No, let's not worry about it. I think another potential approach is, let's lay the groundwork. So, asset management is a super hard problem, no matter what those assets are. And even if you want to do kind of a patch everything compliance regime, you can't really do it if you don't know what you have. And so that can be a good first step, in my opinion, is just like, well, let's hold off on that until we know everything we have. So I think that can be more useful for a lot of different kind of next steps. So it's not easy. I know it's easy to say, well, just do asset management, it'll be easy. But I think asset management is a good foundational control. And then from there, you can start to think about, well, okay, we have all these vulnerabilities. Maybe we can start to cut them, only ones in prod, maybe, or only ones with internet exposed services, or maybe only certain categories. That's one like simpler approach. From there, again, I would want to take advantage of your language and your stack is a good fit for some of these reachability controls. I think that's a really good start. If you can kind of sell your stakeholders, or if they trust you to own this. I'm just been such a big fan of the work I've seen in this area that, again, if your stack is the right fit for some of these tools, I think that's a great way to kind of, you could set a flag in your pipeline pretty much of, oh, if it's reachable, I can keep its severity. If it's not reachable, just put it to a P5. And everyone knows P5s never get fixed. So move on from there. Another approach, and I won't dwell on this too long, but there's other approaches, I think, particularly for infrastructure vulnerabilities, to focus on that for a second, where you have these ideas of like pre-patched or golden images, where you just dump all the patches in them and you rely on having really good testing for your development teams. I've maybe worked at one place where I would trust the testing to be robust enough to catch that sort of thing. But if the organization's mature enough where you can get regular testing in place where you're confident your patches won't break stuff, then pushing out these hardened images on a regular basis is another approach that I'm personally a fan of. Of course, easier said than done. You have to have all the pieces working, like QA, development, Dockerized containers, et cetera, before that'll work. But that can be another way if you really have to get, everything patched.
No, I'm with you there. Like, what I've seen is that, a lot of companies generally are like in a very like different phase of like where they are as a company to be able to do like golden images, or like, even if you take it like a look at like, it could also just be dependencies, right? People might be pulling in dependencies that they know that we're not supposed to be using. The security team says you should use our internal library, but they still go ahead and do it anyway. Like that's kind of like, you're not going to stop people from developing, right? You have to still let that through, but like, what is the path forward to kind of make that successful? And I think that's kind of like some of the questions you might want to be asking yourself before trying to like find solutions, right? It's like, there are obviously maybe like cross-functional kind of problems that you need to kind of solve first before you can start putting tools in the mix to try and solve these problems. I did have something on my mind around asset inventory. Is a really interesting domain, right? Because of like, things like SBOM, whatever. The biggest thing for me is like, if I was an organization, the thing about like, it's great that you can build an SBOM. The one thing I need to know is like, can I query everything to like find out when like the next log4shell comes out, right? Like that's the biggest thing I think that's probably going to be coming out in the market in general, right? It's like, I want to know, like, regardless of what my tools are doing, I need to be able to know, like, in like within 10 seconds, of querying something, like, what are my potential risks, regardless if there actually is a risk, right? And I think that is probably something that I think really people should be thinking about as well.
Yeah, I like that. I think that is one of those things where that's like a legitimate SBOM use case is exactly what you're talking about. Like, not only for my own custom code that I'm running, but as a defender, I want to know what are the dependencies, what's the underlying stack for a random vendor that I've approved, but I didn't have the resources to go read through every single line of code. So, I mean, I don't know how your experience was, but my experience in these sort of log4shell type situations has been, honestly, the places I've worked, we've been able to deal with what we need to deal with for our code pretty quick. We as a company or organization know how to deal with incidents and emergency patches. What's hard though is when the vendor takes a month to patch and you didn't know they were using Java or something, right? That's more of a difficult scenario. Or someone deployed something 5 years ago and never told anyone. How do you even know that you need to go talk to that vendor? And I think that's where, as like a defender, I would love to have an SBOM is for our vendors. Even though I think it's not the cure-all that some people pitch it as.
Oh, definitely. I mean, like most solutions are not the cure-all, right? Like I think if you're just relying on one tool to solve the problem, I think you might want to take a step back and rethink that, because there's definitely going to be a lot of limitations with whatever tool you're using, and you need to obviously think of the other mitigating controls that you can do. From like an SBOM perspective and just dependency management perspective, I think it's not even like if you take like 10 steps back, it's actually a lot harder than that. You need to know who the owners of the platforms are, especially in large enterprises that, it's like in a smaller team, it's a lot easier, go talk to this person because they're the owner of all these stacks. But if you go over like, acquisition heavy companies or companies that, they might not even know who the owner is of a product. And they probably spent the first like 7 days figuring out who the owner is so they can ask them to fix it. So there's, a lot of, from like an asset inventory or like, even understanding where things lie is probably one of the kind of core key pieces, I think, is what would make someone, very successful to kind of mitigate the next, vulnerability that comes out, even if it's like not as critical, but you want to be able to get that information quickly and make sure it's patched quickly, because putting things in Jira just doesn't work. There's a lot of human interaction that's generally required until you can get to a more automated state. But the human aspect is probably the key thing early on, I think. Could be wrong, but that's my take.
No, I like that a lot, and I think it's great. There's so many pieces of this. We could talk 5 or 8 hours on this whole topic of like third-party vulnerabilities. There's so many aspects we haven't even touched on. I think you're totally right. I think you're also super right mentioning that companies with lots of acquisitions, for example, have a lot of challenges, I think, in all areas of security. And I was just going to say that I've worked at companies that have had literally 0 acquisitions, and comparing that to a 30, 40-year-old company that essentially is at this point composed solely of acquisitions, even if it's a 5 or 10 person team. Like, the security challenges there across the board, it's crazy how difficult it is, in my experience at least, to have any sort of security controls or insight when everyone's on their own stack, their own AWS account, their own expensed business credit card, paying for it.
Yeah, I never want to go and look at Concur again in my life, but that's a different conversation. We'll take one final question, and then we can call it a day. What would you say are the key features that are crucial that is, let's say like a solution you build or a solution that you buy that, it must have like the key characteristics to be able to, do components of supply chain well?
Yeah, good question. I mean, I think fundamentally, like a table stakes thing is that it needs to be able to find CVEs in packages. So, oftentimes it's as simple as a database of version numbers and then being able to parse the different manifest files. So I think we'd all agree that's an important step. I think that for me, if you're a product that I was going to be going to my boss and asking for budget for, it would need reachability for a large portion of our stack, just wherever I'm working. Because again, I'm just really a believer on this idea of reachability analysis as a game changer. And I think you see it in the marketplace. Everyone's kind of coming around to it. It's just a matter of how quickly they want to or are able to add that for different stacks. And depending on how popular your language of choice is, or how many languages of choice you have at your company, that could be a deal breaker or not. And then I think just good integrations. This is also almost like table stakes. Just, you want to be able to pull data out, whether it's pushing it somewhere or Serif output, whatever works best for what kind of tooling you have. But any tooling that expects you to be living in some web UI, like clicking, ignore resolve on vulnerabilities, is one that no one is ever going to use. So a tool that is built with the intention of pulling the data out and doing something useful with it is, again, that's really the only kind of tool that I want to have to work with.
Got it. So all I'm hearing is API first companies, please, always, first and forever.
Yeah, I think it's hard when a lot of people, it's human nature to buy the shiny, pretty thing, right? You see the pretty API and you want to go with that vendor, but maybe not the best choice, depending on the company.
Depending. Well, that's a great place to stop. This was episode 22 of SecuriTEA and Crumpets. Thank you so much, David. This has been a great conversation.
Thank you, Lewis.
All right, and everyone, make sure you please check out the Egress filtering in AWS at CactusCon or when it comes out on YouTube. So, till next time.
Great, thanks.